But again, I think I asked, right, 50, 60, 70, 80% of you had already have had calculus somewhere along the way. So I don't know why we don't require it. Anything in Chapter 5 we need to chat about before we get to the exams, or anything else you want to do? We okay there? Yes, ma'am.
Did we talk about effective rate calculations?
No, we did not. All that is basically is looking at, say, a rate of return compounded. You know, we've talked about annual compounding, doing it semi-annually, doing it quarterly, doing it monthly, doing it whatever. I don't generally do that because I assume most of you understand that the more often something compounds, the better off you are on the receiving end and could actually do that. If you'd like me to show you that, I'd be happy to. It will not be on the exam because we did not cover it in class. But it's actually in your book, isn't it? They probably use like a 6 or 12% rate of return that's easily divisible by 12 eventually, and 3 and 4. And you can see, what was the rate they used in the text? Is it 12? 12 is my favorite because it's divisible by 3, 4, and 12. So you can go quarterly, monthly, and semi-annually, or 3, 6, and 12. Is that what they used? 12% maybe? Okay, this obviously made a hell of an impression on all of you. At any rate, if you find out that the more, you can actually take an example I typically use, I take 12% rate of return. That never changes, but as you increase number of compounding periods, it becomes a return in effective rate closer to 13 than it is 12. Do you remember when Jason was talking about trying to get the people in the military to realize they had a 10% savings account? And the one guy said, well, it's really not 10%, it's 2.5, 2.5, 2.5, 2.5. Didn't realize that's a whole lot better than 10%. Do you remember what we did there? It's a 10% rate of return for a year, but it's actually compounded quarterly. So we took 1.025, we divided the 10% rate by 4 to recognize the 4 compounding periods per year, and then we took the power that we were raising it to, and you multiply that times 4, right? Because in 1 year you have 4 quarterly compounding periods, and I think if my memory serves me correctly, we came up with, what, 10.38% or something. That's exactly what it is. So we actually did do it, but it's still not going to be on the test. Okay. And that, by the way, that what Jason ran into is not, you know, we talked about my talking to some of my wife's colleagues about the federal program. It's like, okay, you can invest 4% of your own money and have 4% of your salary after taxes, and have 15% of your salary invested in your name. I don't think so. You know, it's the financial illiteracy in this country is beyond comprehension. And many of you, I mean, you read the stories about people that do things that are financially mind-boggling and they think they're perfectly legitimate. It probably does not come as a surprise to you that would be the case. You need to be thankful that you're probably not in that group, or hopefully you're not in it. Yeah.
I remember you had said something about, I think maybe it was annuities due.
Yeah, we are not dealing with annuities due. Good point, right? When will we talk about annuities due? And I hope we get there, really do. And I think with this group we probably can. Leasing. Because that's the only time you will typically encounter an annuity situation where the payment is due the day you walk out of the dealership, typically with something. And the dealership could sell cars, boats, planes, trains, you name it. But leasing, for whatever reason, we have gotten to the point where making the first payment on the day you get the asset has become standard procedure.
And you had also said that we would need to know 9 different equations.
No, 5, I think, right? We need to know the 4 from chapter, it'll eventually be more than 9, but if I said 9, I'll apologize right now. It's 4 from chapter 5, right? The future and present value of an individual amount of money, the future and present value of an annuity. And remember, all of those equations are based on 1 plus I to the nth power. You know, it's there somewhere, right? And then the 5th one is the equation for the security market line. That K sub J is equal to K sub RF plus KM minus K sub RF.
Yeah, I thought there were a couple more in chapter 6 that we needed to know.
Now, we could have talked, you know, if you want, we can throw Markowitz in there. But that may have been where that came up, because, you know, Markowitz is not there. let's see, 6 was the, yeah, I would not ask you to compute a standard deviation, although we did chat about that in class. I would certainly not ask you to, by hand, compute a correlation coefficient, even though you could.
So it's the 2 present value, the 2 future value, and then that final equation we went over.
Yeah, the security market line, yeah, which would have been the last equation we did, I'm sure.
Okay.
Because the CAP-M is the last thing we talk about in that series of not strenuous at all for folks of your caliber, I hope.
Just because there's a couple of other ones, and maybe these are just kind of related to the future value and present value ones that we already talked about, but like the future value of an annuity interest factor.
Well, that FVIFA, that is what you get out of the, here, that's a good point, right? Because there is, you've got, your tables in there, the future value interest factor for an annuity is literally this. Whoops. Okay, remember, this is how we computed the future, and when we actually did one of these future values for an annuity, we had the future value of an annuity is equal to the payment times this, okay? But this calculation is the future value interest factor for an annuity. The other one would be the present value interest factor for an annuity, right, if we were coming back to the present time. So, again, and sometimes 1 plus I to the n is called a future value interest factor. 1 over 1 plus I to the n might be called a present value interest factor. And if we were going to use those tables, you would have to be very familiar with those names. But since we're not going to use the table, you can call this a step ladder for all I care, as long as you know how to use it. Okay? But that's a good point. That is the future value interest factor of an annuity. Okay? And that should be, if you look in the text, that probably is shown that way, I would think. They should give you that mathematics that you're responsible for. Anything else in 6? Or where the hell are we? 5. Yeah. Now is the time, folks. Okay, 6. 6, we talked about standalone risk. We talked about the risk of a non-diversified portfolio. Standalone risk is measured using what? No. Coefficient of variation. Yeah, remember, the standard deviation is not sufficient unless you happen to be dealing with 2 securities that have the same expected return, like our example was. Okay, ordinarily you want to go to that last step, compute the coefficient of variation, because that's and when you get to that point, you can't screw it up. You don't have to worry about whether the means were the same or not. We talked about in the Markowitz situation, his 2-stock non-diversified portfolio. That's where our correlation coefficient came into play, right? Because we know that depending on the way the 2 securities in that portfolio behave relative to one another, that will determine the level of risk reduction that we can get. The less alike the securities are, the more risk reduction we get by combining them in a portfolio. And the correlation coefficient is an outstanding measure of that. And remember, correlation coefficients measure the correlation, if you will, between 2 things, not among several things, right? You have to, if you're comparing things, a correlation coefficient is only good for 2. It's A to B, and then A to C, and B to C, or whatever, but it's not A to B to C, or B to A to C, or, it is a bilateral statistic. But Markowitz figured out that literally you do not put, we showed mathematically, as I said, what your grandmother had been telling you for years, you don't put all your eggs in one basket. He was the first person to show that. One of the reasons why he is in possession of a Nobel Prize. Because that laid the groundwork for everything that came after, including Bill Sharp's capital asset pricing model, which, if you remember, was the last thing we talked about. Remember, you can't use the CAP-M, you can't talk about beta unless you're dealing with what? Securities as part of a diversified portfolio, right? And again, it's not difficult to diversify. You can do it costlessly by buying index funds of one variety or another, and you don't have to have terribly many stocks in that portfolio, right? 25, 30 randomly chosen securities will typically do it. If you choose those 25 or 30 stocks out of the automotive manufacturing sector and automotive suppliers, even though you have 25 or 30 shares, do you have a diversified portfolio? The answer obviously is no. Okay, so